This is the 9 a.m. Zoom meeting for Math 2460, Friday, October 2nd. Appreciate y'all coming out early on a Friday morning. It looks like I got 3 other people here. Y'all got any questions this morning?
I thought we have quiz this morning. I think I did not receive the quiz yet.
Now, there's a very good reason for that. I've had 2 tests this week to give out in the other 2 classes, and I lost Wednesday, taking my mother around to an important doctor appointment. Haven't even made it up yet.
Professor, you feel better now?
Yeah, well, my mother feels better now. Yeah, but
Oh, sorry.
no problem. But yeah, so I'm behind, and hopefully it will be out sometime today. But this is Friday, and I got family things to do. It'll get done probably sometime today, and with any luck, posted by tomorrow. We won't change the due date. It's technically, that would be too confusing. We'll just technically still make it due Sunday night. But if I get it out a little too late for y'all to get it done by Sunday night, of course, there's no late penalty. But it will be available hopefully sometime today and no later than tomorrow morning. Maybe I should write that down. I believe it's quiz 6 will be available. Either, I should say, either today or no later than tomorrow morning. This is probably going to be the longest one I've ever written out. These problems are long. If I do 5 problems in 8.4 and 5 problems in 8.5, it's going to take me a pretty good while to write them out. Remember, some are supposed to be correct, some incorrect. So it takes a good while to write these out. Did anybody want to see any of these? Available. Did anybody want to see any of these? Morning. 8.4 was about trigonometric substitutions, and 8.5 was about the partial fractions. I only got to the first case of 8.5, distinct linears. Did you want to start there, or did you want to see any partial fractions first? I'm sorry, or any trig subs first? Not getting a whole lot of response. Just, I guess, pick up where we left off from Tuesday. We have this section. I've already done pretty much a case like number 3. That'd be, you factor this, x plus 3, x minus 3. I've done a similar one to number 5. Number 7 is going to be longer. By the way, watch for the cases. Some of them, notice the x cubed on number 9, x squared on bottom. You've got to start that with long division before you even start partial fractions. Let's see, don't see any other cases of that. It looks like the only one that I spy, top power is bigger than your bottom. Yeah, that looks like the only case of long division I see. Does that jog anything? Anybody want to see anything like this? Did y'all even hear me?
We can do one of those problems. That sounds good.
Okay, can you pick out one? Because I can't, I'm not a parallel processor.
Can we do number 15?
15 right here?
Yes.
Okay. So this is off page 557, problem 15. Integral of 9 minus x squared. And you have 7 to the x to the third, add x dx. All right, so you want to factor. So it's not a square letter number pattern. It looks like it's just always look for a common factor first. Looks like it's x. And that'll leave us 7x squared add 1. So you have an integral of 9 minus x squared over x, 7x squared add 1 dx. All right, so the idea is to expand your 9 minus x squared over x, 7x squared add 1. And that means you're going to stick, you got a linear piece of your first power, that's an a over the x. And notice that's quadratic. So I will stick a bx plus c over my 7x squared add 1. Questions about that?
No.
Okay. This is completely arbitrary ordering. I mean, I could have done an ax plus b over this first and then a c over the x. It's completely arbitrary ordering. Now, what you want to do is put this together. So that means you will get an a. In other words, if you put this together, you run this up there and you run that up there. So you get an a times your 7x squared add 1. And in x, parentheses, bx plus c. And that's all over your x and 7x squared add 1. Now remember, we started with this. So you really bring this down and you really have 9 minus x squared over your 7x cubed add x, which is your x, 7x squared add 1. See, this equals this. And the bottoms match. So you're really setting 9 minus x squared, setting the tops equals a 7x squared plus 1 plus x and your bx plus c. Now, the long, slow way is 3 equations, 3 unknowns. 3 equations, 3 unknowns. But we talked about a magic number. If you look at your individual fractions, x equals 0 will be a magic number. And it will tell us the a. There's going to be no adjunct. We'll then have to do a 2 by 2 because there's no magic number for this. You can see if I set this equal to 0, I get 7x squared is negative 1. X squared will be a negative 1 over 7. Do a square root, I get some sort of I. There's no x here that makes this 0. All right, before we charge ahead, should we pause for station identification?
It makes sense so far.
Okay. Are we ready to plug in x is 0 into this and figure out the a?
I think so.
Okay, so we got 9 minus 0 squared. I'll do it real slow, but you can probably do it in your head. Because you see 0 is going to kill all that. You get your a, 7, 0 squared add 1, plus 0 times b times 0 add c. I'll just do it for completeness. You see on this side, you get a 9 equals A times 1, which means A equals 9. Magic. So this first fraction will have a 9 over x. Questions about that? All right, unfortunately, there's no other magic numbers. So this is where more magic comes in. Remember, results are independent of x. There's no other obvious x to use, no other magic x. So literally, you can make it up. You can use any x you want. You could use 10 million if you want. That's a lot of zeros to write down. So we've already used x. You can't repeat it now. X is 0 will just tell you the same thing. So we've already used 0. I'll use x equals 1. So I'm going to plug x equals 1 into 9 minus x squared. It's off the page. I'm plugging it back into the same equation. Let's see. Get that off. I'm using this equation, and I'm going to plug in x equals 1. And I just made it up. Very few spots in math class you can just make stuff up. This is one of them. It literally does not matter what x you use. So I'm plugging x equals 1 into 9 minus x squared equals a. 7x squared add 1 plus x bx plus c. 9 minus 1 squared equals, now you also want to plug in your a, because you're going to get an equation in b and c. So you already know your a, that's given. I'm not given, but we figured that out. A was 9. Yes, a was 9. All right, 7, 1 squared, add 1. 1 for that x. B times 1, add c. In equation, it's really just plug and chug. Just a lot of algebra, but a lot of ways you can mess up the arithmetic and signs and everything here. Now this is going to give you 8 equals 9. Looks like the parentheses are going to give you an 8. And then this one doesn't change in b, plus, you're going to get a plus b plus c. 9 times 8 is 72. Plus c, subtract 72 over. Negative 64, 8 minus 72 is probably negative. Yes, negative 64. B plus c. I'll just write it over here. Collect my equations. B plus the c, add to negative 64. The best I can do, pretty much. Have we lost anybody? Everybody is so awestruck, you're speechless.
Yes.
Okay. Do you all want to give me the next x? We could, just to show there's nothing up my sleeves. I got no magic x's in my pockets. I usually use small integers, 2, -1. But I had a class one time made me use 39. And we were there forever. The bigger you go, the longer it takes. You see how long it is already. But I had a class that made me use 39, and it worked. I mean, they were just kind of awestruck when I filled board after board with arithmetic using 39, but it eventually worked. Y'all have a preference X?
Now we could try number 2, I guess.
Is X equal 2?
Yes.
Okay. So once again, it's the same equation. 9 minus x squared equals a 7x squared add 1 plus x bx plus c, and we're going to use x equal 2. That's, I guess, one of the maybe the tougher things. Everybody's used to using some sort of logical thing for the x, and that is where you get like the x equals 0. But if you run out of logical places to get the x, you literally just make it up. All right, 9 minus 2 squared. A was 9. 7 times 2 squared add 1 plus 2 for that x. B times 2 add c. All right, so 9 minus 4 is 5. 9. We got 29 there, don't we? 4 times 7 is 28, add 1 is 29. And you're going to get a 4b add 2c. Distributing the 2 through. All right, 9 times 29, what the heck is that? 261 plus 4b plus 2c. All right, so minus 2, put the 261 over. 5 minus 261 comes up negative 256. 4b plus 2c. Now, again, you can play with the algebra any way you want. There's no real way to simplify that equation. We've got to put these two equations together. Notice how everything is even. So if you wanted to, you could just divide everything by 2. And that should give you negative 128 equal to 2b add c. But you don't have to do this. There's a million ways to do it. If you want to call this equation 1 and this equation 2, I'm going to bring this one down. And I guess I'll write it here. B plus C was equal to negative 64. All right. Before we proceed, any questions about collecting those equations?
Not so far. I think everything is clear right now.
Okay. Now, again, favorite, you could solve for either B or C. Here, plug in, that B or that C, plug in. I just looking at this over, I always like to add them, but you see, you got to have, I could do the negative 2 down here and add and get rid of the B's, but I guess I'll just do negative 1 here, and I can add and get rid of the C's. So I'm going to multiply this one by negative 1. Again, I think there's like 6 ways to proceed, depending on what you solve for. 4 letters to solve for, or 2 numbers you can multiply through. All right, that makes the equations negative 128 equals 2b add c. And if I multiply that bottom by negative 1, you do that in your head, that's going to make it 64 negative b minus c. Negative 1 switches that sign, switches that sign, switches that sign. We now add, C's go away. We wind up with B. And negative 28, I think it's going to be negative 64. That's going to be a negative 64, right? Yeah, negative 6. So B is negative 64. And now we can plug that into either one of these. And get it on screen. I guess I'll use second one. Negative 64 was equal to B plus C. And if B is negative 64, you see C is 0. Negative 64 plus C, C's got to be 0. I'll just show you what all of this proved. At least it proved it to me. It proved that the original, or showed, that 9 minus x squared over the, what was it done? God, I'm under my third page. These things are nasty. Over 7x cubed add x. Add x can be written as the a, it was a over the x, which was 9 over x, plus your b, it was bx plus c. Remember what we had expand, so that's 9 over the x, bx plus c. The b was negative 64x over your 7x squared add 1. B was negative 64x, c is 0 over 7x squared add 1. Okay, I hope you all believe this. That's a lot of algebra. Is there any unbelievers out there who want me to get a common denominator on this and prove it goes back to this? Or do we all believe? We're so awestruck, no one can speak.
I believe you, but if someone else wants to see it,
Is there anyone out there who wants to see this combined back to get this? Or we can just go on and do the integrals again. I remember it was an integral of this, so it's an integral of this. And we can just go on and figure out the integral and check the answer in the back of the book and find out if I'm an idiot. I actually am an idiot, but a real idiot. Y'all want to proceed on with the calculus?
that sounds good.
Okay, so yes, we had an integral of this. That was the entire original problem. We haven't done a lick of calculus. It's been 3 pages of algebra to show that we get this, to bust it up and get this. Can you do the first one? It's a log, 9 log x. 9 log of x. I can put an absolute value if I want. I'm pretty slack about that. And then I'll make it minus 64 integral of x over 7x squared add 1 dx. You can leave the 64 in if you want. Do you recognize a u du integral here? You got an x squared here, do a derivative, you'll get an x. You just have to finagle the numbers. So this one makes u is 7x squared add 1. The du is 14x dx. 2 times 7 is 14. You subtract 1, get x. So that means I need a 14 and over 14 to cancel my 14s. So that means I'm going to get a 9 log of x minus 64 over 14 integral 1 over u and du. Remember the bottom is u and the 14x dx, that's all du. That's another log in u. Are we losing anybody so far?
It makes sense so far.
Okay, 9 natural log of x. I guess we'll call this 32 over 7. Book probably will reduce that. Natural log of u plus c. And the u is 7x squared add 1. So here's my answer, final answer. 9, natural log, absolute value of x minus 32 over 7, natural log of 7x squared add 1 plus c. Might be worth looking it up. That only took 25 minutes. Let's put a whole bunch of these on the test. Am I getting the mood of the room to put a whole bunch of these on the test? Let's find out how close I got. Never work these out in advance. I make my mistakes in front of you in real time. Let's see how close I got. This was 8.5. Oops. 8.5. Problem, it was 8.5. Which problem was it? 15. 8.5, problem 15. Well, I should go play the, no, we got it. Here we are, problem 15. 9 natural log of x, there's the 32 over 7, natural log of the 7x squared add 1 and plus c. Are you all as awestruck as I am? And just the thing you got to realize, just make this point about it, is that when we were plugging in x equals 1 or x equals 2, you could have used anything you wanted. Now, you would have gotten different equations using different x's. They would have been different equations, but they would have all, and this system would have looked different, but it would have all resolved itself, and you would have worked right back to the exact same A there and B there and C of 0. Does everyone believe that? Or do you want to use completely different X's and spend another 25 minutes making that point? Or do we all believe?
I think we all believe.
We believe. All right. You can see they take about 25 minutes a problem. So in an hour Zoom meeting, not too many you can work. I haven't shown you a quadratic case. Would you like to see that, or would you rather see a trig sub?
If we have time, I'd like to see both.
Which one?
We can start with the quadratic.
Oh, a quadratic?
Yeah.
Okay, now actually, now I think about it, I just did show you a quadratic. Let's see. 17 probably has quadratic forms in it. Do that x to the 4th. You want to see something like that?
Yeah, that sounds good.
Okay. Start on the top of a clean sheet of paper. This is page 557, 17. You got x squared over x to the 4th minus 2x squared and minus 8. All right, if you're rusty on your factoring, notice it looks like two numbers, multiply to 8 and add to -2, -8 and add to -2. With the x to the 4th, though, it's going to go like an x squared, minus 4, and an x squared plus 2. You see the FOIL back in your head, x to the 4th, you get a 2x squared minus 4x squared, there's your -2x squared. And -4 times 2 is your -8. You recognize this pattern. That's your difference of squares, x plus 2, x minus 2, and x squared plus 2. You can't break that down. Number 1, 2 doesn't have a root, clean root. And number 2, you got a plus sign. So this is the best you're going to do. So we've worked it to x squared, and on bottom, and x plus 2, x minus 2, and an x squared plus 2. dx. Have we lost anybody? Can you see the expansion? I'll keep it in integral form for right now. You're going to have an a over your x plus 2, a b over your x minus 2, and this is quadratic. That's going to be a cx plus d over your x squared plus 2 dx. This is going to be a royal pain with 3 of them here. This is going to be kind of a royal pit to put this all back together correctly. Are we ready to put this back together?
Yes.
All right, remember on your bottom, you're going to want all 3 pieces together. X squared plus 2. Okay. Now, you just got to think, remember, this has got to go back and leave a over x plus 2. So can you see you got to have an a times your x minus 2 times your x squared plus 2. May not have left myself enough room to do this. You see that the x minus 2's would cancel, x squared plus 2 would cancel, and you're left with your a over your x plus 2 back up here. All right, can you kind of see the rule? You did a times the other 2 bottoms. And that's the way where b will be times the other 2 bottoms, and the cx plus d times these 2 bottoms, the other 2 bottoms. So the b will go times its other 2 bottoms is x plus 2 and x squared plus 2. Should we pause for station identification? See, if I actually canceled this, I'd be left with the b over x minus 2. And I'm out of room to write the cx plus d. Maybe I'll do it up here. I'd have cx plus d. Its other 2 bottoms are x plus 2 and x minus 2. Parentheses. Maybe I should write it, maybe too compressed. Maybe I should write it out one more time here, real more compressed. So it's the a times the other 2 bottoms. X squared plus 2 plus the b, the other 2 bottoms are x plus 2, x squared plus 2, and the cx plus d, and its other 2 bottoms are x plus 2, x minus 2. And all of that is over all 3 pieces, x minus 2, x squared plus 2. Should we pause for station identification? Everybody's so awestruck, no one can speak. This makes perfect sense to me.
I think we're good to go on.
Think so?
Yes, sir.
Remember, you want to set this equal to the original top up there, x squared. So here's your equation. You got x squared, again from here, you want to set that equal to that top because the bottoms match. So you got x squared, I'll write it out real slow again, a x minus 2, x squared plus 2, b x plus 2, x squared plus 2, and your cx plus d, x plus 2, x minus 2. Once again, the long, slow way would be a full 4 equations, 4 unknowns. But can you see the magic number that'll tell you the A? -2, right? Stick a -2 here, and I'll find out the A. Are we ready to start into that?
Yes, I think we're ready.
Okay, so x equals -2, we'll find A. So -2 squared there is 4 equals A, -2 minus 2, -2 squared add 2. And can you tell, can I really shorten up the writing? See, -2 plus 2 gives me a 0 there. And -2 plus 2 gives me a 0 there. These last two pieces die. So it's a matter of figuring out these parentheses and divide both sides by it. I'll know my A. So I get an A, that's a -4. This is a 6. 4 plus 2 is 6. So 4 is -24A. Divide by -24. And that's a -1/6. My A is -1/6. Trust me, that's a heck of a lot quicker than a full 4-equation 4 unknown. Even as long as that might look. Do you see the magic number to tell you the B? +2. Are we ready to plug it in? Find out the B? I know the suspense must be killing you. Hearing no objections, we'll go on and find the B. So x equals 2. I'll try to leave. Oh, maybe y'all can't hear me. My internet. Okay. We're going to use x equal 2, and we're going to find B. I'll leave the equation up. My internet will catch up. Oh boy. Okay, it's trying. Okay, maybe it's slightly back. Okay, so I'm gonna use x equals 2. 2 squared is 4. A is -1/6. You got to plug in everything you know. Actually, I didn't have to because I'm getting a 0 and 0 squared add 2. Yeah, I should have just realized that. That's going to drop. X equals 2 is going to drop this plus B, 2 plus 2, 2 squared plus 2, and x equals 2 by that factor drops the rest of it. So yeah, I didn't really have to write this down. Forgot about that. So I'm getting 4 equals B times 4 times 6. 4 equals 24B. Divide by 24. And it looks like your B is 1/6. All right, I now know the A is -1/6 and B is +1/6. All right, rest of it, to find C and D, you make up X's. Plug in the equation. Y'all want to pick the X's so there's nothing up my sleeves? Somebody give me an X.
1.
All right, use 1. I'll give you a hint. Not that I don't like 1, but 0 is always a nice X to use. If we haven't used it, and we haven't. We've used -2 and we've used 2. You want to start with 0?
Yeah, let's start with 0 then.
It really simplifies. 0 and 1 do really simplify things. So we use x is 0, it's like our third cut at it. We wanted to cut. Everybody know what we're plugging into? Do I need to rewrite it? Plug it into this mama equation right here. Do I need to waste your time rewriting it, or can we all just plug into it? Try to keep it visible.
We can just go into it.
Okay, so 0 squared. A is -1/6. 0 minus 2. 0 squared add 2. B is +1/6. 0 plus 2. 0 squared add 2. And I'm going to run out of room. So I'll come down here plus C times 0. So actually, this is going to tell me the D. Add D. 0 plus 2. 0 minus 2. That's nice. I'm not going to get 2 equations and 2 unknowns out of this. I'm going to find directly the D. It'll catch up. Darn internet. Having some internet issues this week. I don't know if y'all can even hear me now. Okay, trying to catch up. See, the only unknown in this will be the D. Can y'all still hear me? Darn screen freezing like this, I can't tell if y'all can even hear me. Can y'all hear me?
We can hear you. It's just your screen's slowly catching up.
Yeah, it's sorry about that. All right, well, I'll try to charge ahead. Let's see if it'll follow. So it gives me 0. It's really nothing but arithmetic. All right, we're going to get a -1/6. All right, it's trying. A -2, a 2, +1/6, a 2, a 2, and then plus a D and a 2 and a -2. None of this is really it's very hard. It's extremely long. And the longer it gets, the more places there are to screw up a sign and, make mistakes. All right, I'm going to get a +4/6. Another +4/6. And a -4D. Please catch up. You think it'd help if I stopped the share and restarted it? Well, it's trying. We're at 43 minutes. Golly, I'm dying to find out what the answer to this problem is. The suspense is killing me. With this darn slow internet. Anybody think it'd help if I stopped the share and restarted it? Maybe that would jolt it. It really seems frozen now. Y'all still hear me?
I can hear you. I can barely hear you.
Barely hear me. Okay. The ad's frozen. Let me stop the share and restart it and see if that'll freeze things. I've seen it work, and there's no guarantees, but I'm going to do that, and I'm going to try to come right back to this. Okay. Might be the darn internet. Okay. Can y'all still hear me?
Yeah, we can hear you.
Yeah, I just so I don't know if it's a load on the system or what. It just the 8 o'clock Zoom worked fine. Maybe it's catching up. Okay, he's trying to come to the camera. Oh, okay. Let's see. So I worked out that line and I got to this. Oh, this is frustrating. It just can y'all if you think you can work it out, anybody work it out and found out what the D is? Kind of blind. It's not going to cooperate this morning. Okay, maybe it's going to come back. Four six and 4 6 is 8 6. Negative 8 6 is equal to negative 4D. It'll catch up to that or not. Okay. You divide both sides by negative 4. Over here, you're dividing by negative 4. Can you see you're going to get an 8 over 24? So D is 1/3. Miracle, we're temporarily back. I hope it lasts. Anybody have any questions about that? Just to recap, we now know A is negative 1 6, the B is 1 6, and now our D is 1/3. So we've worked out 3 out of 4. And it's frozen again. Okay, caught up. Y'all ready? Y'all got the patience to plug in X? Now we'll use X equals 1, which is what you suggested. Plug in X equals 1 and figure out what our C is. The suspense is killing me. Y'all ready for that?
Yes, sir.
Okay. I know the equation to plug into. This is like our 4th attempt. X equals 1. Internet connection is unstable.
Like a whole 3.
I'm sorry, what now? I heard someone say something. You want to say anything or? One squared equals, all right, here's our equation. All right, we got our A is negative 1 6. I can almost use this and stick it where the zeros are. So I've got 1 minus 2, 1 squared add 2, plus 1 6, 1 plus 2, 1 squared plus 2. All right, and then finally a C times 1, add the D, what was D was 1/3. 1 plus 2, 1 minus 2. Anybody have any questions about that? It's really just plug and chug. And the rest of this, just figuring out what the parentheses are. And yeah, we're going to find our C.
I don't have any questions.
No questions, okay? So 1 is equal to negative 1 6, negative 1 there, 3, plus 1 6, 3, and another 3. 1 plus 2 is 3, 1 squared plus 2 is 3, plus C plus a third, 3, and a negative 1. Did we catch up with me? God, this is getting painful. Apologize for this. It's getting worse and worse and worse. Maybe it'll eventually catch up. I'll keep working it down. Oh, okay, they're caught up. So I got it to this. The 1 minus 2 is negative 1. 1 plus 2 is 3. 1 plus 2 is 3 there. 3 there. C plus a third. 3 there and negative 1 there. I'll keep going. Maybe it'll eventually catch up. You'll get a 3 6. 9 6, C plus a third times a negative 3. So 1 equals 12 6. And you're going to get a minus 3C and a minus 1. Twelve 6 is 2, minus 3C minus 1. I don't know if you, okay, I threw up a lot of lines all at once. I get a 3 6, 3 times 3 is 9 6, C plus a third, get a negative 3 for there. 3 6 9 6 is 12 6. Distribute the negative 3, minus 3C minus 1. 12 6 is 2. 1 equals, and 2 minus 1 is 1 minus 3. All this work, and what did we find out? Darn C is 0. Okay, are we ready to proceed with the calculus? The A, just to remind everybody, A was negative 1 6, B was 1 6, D was 1/3. Can we plug and chug into the calculus? Just, I know we're getting close, we're 55 minutes, I know we're getting close. Basically, we're having an integral. I'll write the expanded format with these numbers in. And the A was over the x plus 2, negative 1 6 over the x plus 2, plus 1 6, that was over the x minus 2. The B was over the x minus 2. C was 0, so we had a D of 1/3, and that's over x squared plus 2. So catch up. This was your A, this was your B, your C, X plus D, and C was 0. So I've written down the integral. It's just a matter of plugging the A, B, and C, X plus C and D into that expanded form if it'll ever catch up.
Yeah, I think it's completely frozen again.
Yeah, it's completely frozen again. Let's see. Well, it's trying. Maybe it'll get down. I've written down the integral. Doggone, we're very close. I'm like, one more line, I can write down the answer. Oh, okay, caught up to the integral. If you look back, your A was -1/6, it was over the x plus 2. The B was 1/6, it was over the x minus 2. You had your CX plus D over this, but the C worked out 0, so you can forget the x term. The D was 1/3, and that's over the x squared plus 2. Are we ready to finally end this madness and write down the answer?
Yes, sir.
And see, the first two are logs, just with these coefficients. And I hope you recognize that's a simple arctangent out of chapter 5. -1/6 log x plus 2. +1/6 log x minus 2. +1/3. Now, if you remember, your general arctangent was x squared plus a squared. So the a squared is 2, which means a is √2. And the arctangent form had a 1 over a arctangent x over the a and plus c. Now, this is perfectly good for me for an answer. The book may play around and rationalize that coefficient. I don't know, but I know I'm sucking wind. That's that one. We're at 58 minutes and bad internet. I hate to ask if anybody wants to see any more. I don't know if anybody can stand anything more painful than that. Anybody have any questions or comments, or are we ready to end? Everybody's so awestruck you're speechless, or you can't hear, one or the other. Anybody want to see anything more, or are we ready to end the meeting?
Looks like we're ready to end the meeting.
Okay, can't stand anymore. I don't blame you. This is really the first meeting with really that bad of an internet, so I have no idea what's going wrong. Apologize for that. I will try to have quiz 2 out sometime today, but like you say, you see how long these problems are, and I haven't even started it. So I'll be working at it off and on all day between other activities, and it could take till tomorrow morning. But it'll be the same format, true or false, put your answers on a Google form. Did I call it quiz 2? So it's quiz 6. Otherwise, we'll end the meeting and we'll maybe see y'all at the next Zoom session next Tuesday. Y'all ready to end?
Yes, sir.
All right, thank y'all for coming out early on a Friday morning. Really appreciate it. And maybe,
Thank you.
Yep, thank you, sure thing. We will see you next week.
Thank you.
Thank you.